the CMB map, it is correlated with the plane of the Earth around the Sun. Is this Copernicus coming back to haunt us? That would say we are truly the center of the universe.
Shalom, my name is Avraham Ben Shalom, and today I want to talk to you about a very important topic, the sun. There are so many topics that we find with regard to how science tries to stipulate certain beliefs. But here we have a major issue. If you believe in the heliocentric model, well then that means the sun is at the center. And therefore, that would require the Earth to be moving. If the Earth was moving, that would mean the Earth would have to be moving at approximately the speed of 1,200 miles per hour in order to do a full revolution of a one complete day cycle. That being said, here we have some major issues here for those who want to believe in this. What would happen if the actual Earth stood still? What would actually take place if the Earth was forced to stop in its rotation? Remember, you have to understand, the actual diameter of the Earth is exactly 7,926 miles. If you want to get the circumference of the Earth, that's 24,901 miles. That circumference is so large that it literally would take for the Earth to be traveling in order to fill a 24-hour period. You'd have to be traveling 1,200 miles per hour in order for it to complete a full rotation from one side to the other side, which is normally the heliocentric belief. However, there are some major flaws with regard to the heliocentric belief. Let's look at one of them. The Bible says in the book of Joshua, and I will quote it. This is Joshua chapter 10, verse 12. And then spoke Yehoshua to the Lord in the day when the Lord delivered up the Amorites before the children of Israel. And he said in the sight of Israel, Sun, stand still unto Gideon, and thou moon in the valley of Ayalon. The sun stood still, and the moon stayed, until the people had avenged themselves upon their enemies. Is not this written in the book of Yashar? So the sun stood still in the middle of the heavens, and hastened not to go down about a whole day. Now, let's look at the logic of those people who want to say and try to prove the fact that the earth is spinning.
Hey, Vsauce! Michael here. The Earth is spinning, and we are spinning along with it. But what if the Earth suddenly stopped spinning? Well, first of all, you would gain weight. But that would be the least of your worries. The spin of our planet is important and literally giving you the time of your life. At the equator, the surface of Earth and everything on it is spinning around at 465 meters a second. As you move closer to the poles, you don't have to move as quickly to complete Earth's daily rotation. Here in San Francisco, the Earth is driving me east at 368 meters per second. If I could float above the surface, independent of the Earth's rotation, the Earth would spin underneath me this quickly. Pretty cool. But of course, when I jump straight up into the air, the Earth doesn't move underneath me because I continue to spin with it. We are all spinning with the Earth, and that is why slamming on a set of magical planetary brakes that caused everything classically called Earth to stop spinning would be catastrophic. Immediately, everything that wasn't Earth and wasn't safely at the poles would continue moving as it had been and be flung due east at more than 1,000 miles an hour. You wouldn't be flung into space because escape velocity is 24,800 miles per hour, but your body would instantly become a 9.5-inch caliber bullet. Well, really more of a supersonic tumbleweed. Because the atmosphere would more gradually slow down, people in airplanes, assuming they could navigate the resulting storms, might have a better chance of surviving. Astronauts aboard the ISS would fare even better, but it is unlikely that anyone would be waiting for them down on the ground. Runways would just be entrances to the new planet-sized graveyard created by the no longer spinning Earth. People really near the poles might be okay, but only at first. Gusts of wind as fast as those near an atomic bomb detonation would blast past the surface and up into the sky, forming worldwide storms of unprecedented magnitude. The friction alone, caused by the now stopped Earth colliding with these winds, would be enough to cause massive fires, unparalleled erosion, and damage to anything strong enough to stay put after the initial braking. The sun would seem to freeze in the sky as days became not 24 hours long, but 365 days long. Without spinning innards, Earth's protective magnetic field would cease to exist, and we would be dosed with deadly amounts of ionizing radiation from the sun. The oceans would surge onto land in tsunamis kilometers high and wash over nearly all dry land before migrating to the poles, where gravity is stronger, no longer held to the ocean basins by the inertia Earth's spin gave them, until Earth itself, no longer bulging an extra 42 kilometers around its equator because of its rotation, slowly compressed into a more perfect sphere than it is now, possibly allowing the oceans to eventually return somewhat. That is what would occur if it actually happened.
So am I to assume, to believe, that when Joshua prayed and asked for the sun to stop, that this event is what happened? That the enemies of Israel were destroyed by this massive whirlwind of 1,000 mile per hour winds which cast our bodies into the air, causing the Amorites to literally come to a cease and end, and victory was given to Israel? I don't think so. Matter of fact, what we have to understand is the importance of why it is that our world is actually functioning the way it is in connection to a find that actual Einstein found with relation to the theory of general relativity. Take a look at this.
About a century after Kepler, Tycho, Galileo, and Riccioli had battled against one another, Isaac Newton arrived on the scene. In his book, Principia Mathematica, he published his now famous 3 laws of motion. As fate would have it, Galileo's intuition about smaller bodies revolving around larger bodies was confirmed and put into a mathematical equation by Newton. Newton's equation said that the force of movement is determined by the mass of an object multiplied by its acceleration. It now seemed that heliocentrism had finally won the great battle of cosmology. Newton also said that the force of gravity is equal to the mass of the first object multiplied by the mass of the second object divided by the square of the distance between them. Since the Sun is more massive than the Earth, the gravity of the Sun is greater and thus would pull the Earth toward the Sun. To compensate for the inward force of acceleration toward the Sun, the Earth must produce an equal and opposite acceleration away from the Sun in order to stay in its orbit. In the heliocentric system, the acceleration is produced by the Earth's circular motion, and the Earth is said to continue the acceleration by inertia. Simply put, Newton said the Earth seeks to move in a straight line, but the gravity of the Sun keeps pulling it inward, and the result is the Earth's circular movement around the Sun. Newton made a crucial distinction, however. He added that, strictly speaking, the Earth does not revolve around the Sun, but both the Sun and the Earth revolve around a mutual center of gravity or center of mass. But since the center of gravity is closer to the Sun, then for all practical purposes one can say the Earth revolves around the Sun. At least it seemed so to Newton and the people of his day.
The fact that there would be a center of mass between the Sun and the Earth seemed to be the clinching argument to settle the heliocentric versus geocentric debate. Since Newton's equation, F equals ma, could be demonstrated and measured in the laboratory, there was little opposition the geocentric position could mount, except to rely on their theological and philosophical convictions and hope that science would gain more knowledge later to confirm those convictions.
Great names from the Enlightenment age, such as Immanuel Kant, who was called the father of modern cosmology, sided with the heliocentric view based on Newton's laws, as did many other famous scientists of that day. Although Kant had theorized about the existence of what he called island universes composed of thousands of stars, at this point in history no one knew much about the stars, except that they shined as points of light in the sky around the Earth. No one knew how big they were, how far away they were, how many there were, or what influence they might have on the question of geocentrism and heliocentrism. By the mid-19th century, however, physicist Ernst Mach and his colleagues proposed that the stars are as big or bigger than the Sun. Telescope observations showed that the number of stars in the universe was enormous, filling every quadrant of the sky. Mach reasoned that since the Sun, because of its large mass, has a great force of gravity, the stars must also have a corresponding gravity, and thus their combined gravity would greatly influence any region of the universe, including ours. Hence, Mach, in opposition to Newton, argued that no place or object in our solar system escapes the force of the stars. Whereas Newton believed the Earth revolved around the Sun against the background of a fixed but empty, absolute, and immovable space of which the stars did not contribute any force, Mach argued that space was permeated by the gravity of the stars. In a word, whereas Newton believed in absolute space, Mach introduced the concept of an absolute gravity. Hence, Mach argued that not space, but matter, which produces gravitational force such as what we find in the stars, should serve as the fixed background to measure any terrestrial or celestial movement. For example, Mach said that the reason we will be pressed against the wall of a rotating amusement ride is that the gravitational force of the stars surrounds us. We feel the stars' ubiquitous force whenever we change direction or accelerate on Earth. Otherwise, we are oblivious to it. A rotating amusement ride, although it moves at a uniform speed, is understood to be accelerating in physical science, and thus we feel the force, otherwise known as centrifugal force. As one modern scientist put it, quote, "When the subway jerks, it's the fixed stars that throw you down," unquote. What this means is that there is a gravitational tension on Earth created by all the masses of the universe, tension analogous to a stretched rubber band. When we suddenly move against that tension, we feel it as a pushing or pulling force on our bodies. This is otherwise known as inertia. Conversely, Newton argued that our body wants to move in a straight line in absolute space, instead of a curved path, and thus always seeks to break off of a spinning carousel. As we can see, Newton's and Mach's ideas about the concepts of force and movement were very different, to be sure. Additionally, Mach's new insight of the universe led him to conclude that there was no difference between the Earth rotating in a fixed star field as opposed to the star field rotating around a fixed Earth. Both systems would produce the identical forces. Consequently, Mach's contribution to science reopened the heliocentric versus geocentric debate. If there was no difference between a rotating Earth and a fixed star field, as opposed to a rotating star field around a fixed Earth, how could we determine which was the reality? In a word, Mach expanded our view of motion beyond the two-body mechanics of Newton's original equation. If m1 is the Sun and m2 is the Earth, Mach said, in a roundabout way, that we needed another m to represent the stars. Newton's laws of motion could still be applied in closed systems in which a limited number of bodies were present. Say, for example, the moons of Jupiter going around Jupiter. On much larger scales, however, that is, the scale of the universe itself, how would Newton's laws of motion apply if the whole star field were in rotation around one central point, and that point happened to be the Earth itself?
The answer is very simple. According to Newton's laws, if the universe's stars were rotating around a fixed Earth, the center of gravity, or center of mass, would no longer be near the Sun, but at the Earth itself. Theoretically, the universe could be positioned in such a way that it would balance perfectly on the Earth, and thus keep the Sun a safe distance from the Earth. The Earth would act as a center of mass for the universe.
Essentially, the whole universe can rotate around a motionless Earth and obey the laws of physics as they are presently believed to function in both Newtonian and Machian mechanics.
So what does that mean? That means the fact that the Earth is the center of the universe. And the Earth is surrounded by the universe. And the universe itself is rotating around the Earth. And all of the mass of the universe is equated as being a part of the actual physical movement, while the Earth is stationary. This rotation is what's called the sidereal rate, by which the universe, in its movement of all the stars and the sun, is actually moving around the Earth at approximately 23 hours, 56 minutes, and 4.1 seconds. This actually is a astronomical difference by which, when we understand the scriptures and we take it for what it really is, it's amazing how much scientists want to deny the validity of scripture. I'll see you next time.